Hi, everybody. In this recording, we are going to do some exploring with rational expressions and rational equations. So those are both E words, expressions and equations, and we really entertain those two words in almost every section on every topic. And what we're going to do with them is when you don't have an equal sign, normally we begin by simplifying. Maybe you add, maybe you subtract, maybe you multiply, divide, combine like terms, reduce, something along those lines. So we're going to simplify rational expressions. And then when you add that next layer to a problem, we're going to solve rational equations. So that means we're solving, if we're solving something, that means we're finding an answer. Typically, if there's an X in the problem, you solve for X. You want to know what does the variable, the thing that can vary, what does the variable have to equal or have to be in order for this equation to be a fact, to be true? So it'll have like all this stuff set equal to all this stuff. And what we find by the end of it, without guessing and checking, like let's be serious, guys, we need to cut that out. That guessing and checking is not necessary when algebra exists. That's what algebra is for us to be able to solve and figure out that answer without guessing and checking, okay? Another thing that we just pointed out was the first 5 letters of the word rational spells the word ratio. Do any of you guys know what a ratio is in math? Like what kind of number, what kind of expression? You could just go ahead and shout it out, Paige.
Like a fraction, or it would be like a number and then like what is like a semicolon? If that is that the right term? And then another number. So give
Like a proportion?
Yeah.
Is that like a number and then another number? Is that what you mean? What was the word that you were trying to say though?
There would be like a semicolon, I think, in the
Oh,
middle
yeah.
between the two.
That's kind of like a proportion, basically 2 to 3. So a ratio or a fraction or a proportion, sometimes we write like that. Okay. But yeah, so that is what a ratio is. So a rational number is any number you can write as a fraction. And if you are not able to write something as a fraction, what kind of number is that? If you cannot write something as a fraction, what kind of number is it? If it's not rational, come on, let's use our common sense.
Irrational.
Exactly, irrational. Even with people, you're telling them like, you're being irrational, you're not making any sense. Let me rationalize with you. Well, yeah, there you go. Okay. So those expressions, expressions like verbal expressions, right? Use those words in a similar way. A ratio, you could have like a proportion, a comparison of two numbers. It's logical and makes sense. An irrational number like pi or square root of something, square root of 3, square root of 5, you can't write those as a ratio of two things. It's a non-repeating, non-terminating decimal. So we cannot do that. They're irrational, okay? Now, from there, I'm just looking for a good example. I mean, I could just make one up, I suppose, but let's start pretty easy, simplifying rational expressions. So if I gave you, so this is for Roman numeral 1 right now. We're just going to dive into some examples. So example 1, if I wanted you to simplify, we're going to simplify all of these. If I asked you to simplify 4 over 12, could you do that? That should be not so bad. How do we simplify 4 over 12? 4 over 12. How does that get simplified? How does that get simplified? Nobody knows.
4 goes into itself 1 time and 4 goes into 12 3 times.
Okay, they're both divisible by 4. So when we simplify or reduce, you saw 4 goes into that. So really what you're saying in your head is the top could be looked at as like a 1 times 4, and the bottom could be looked at as like a 3 times 4. Right, Jabari?
Basically, yes.
Okay, so you saw 4 went into both of them and how many times, and then what happens with those 4s that you're pointing out?
They cancel out, I think.
Okay,
Well, the
cancel.
top one does.
No, you're right that both the 4s are going to go away. But we don't want to use the word cancel because cancel makes something a 0. And when you're dealing with a fraction or ratio, we don't get 0, we get 1. So we want to say they simplify or they reduce. Cancel is reserved for when something turns into 0, like positive 2x and negative 2x adds to 0x, and that's cancel, all right? So what is going to happen is the 4s are going to go away, bye-bye, and you're left with 1 over 3. So that's what it's simplified to. So that one's pretty straightforward. What about this next example? So example 2, if I said simplify, something like 2 over 3 plus 5 over 4. What if I asked you to simplify something like that? Even if you don't know exactly what the answer would be or precisely what to do, can you help me get started? Simplify those two things together. There's a plus sign in the middle. You could just go right ahead and shout out. Go ahead.
Wouldn't you like multiply both fractions? Like, so for 2 over 3, I would multiply it by 4 over 4.
Good. I like that you're not saying just multiply by 4, but you're saying 4 over 4. That's important because 4 over 4 is really equal to what?
1.
Exactly. And 1 is what we call the multiplicative identity. You're allowed to multiply by 1 all day, every day, and it doesn't change anything, okay? You are who you are. You change your hairstyle, you change your outfit, you're still you. So this is just changing its outfit. So 2/3 will look different. Right now, 2/3 is simplifying. We are basically unsimplifying 2/3. We're building it up a certain way so that we can add these. What do you do next?
And then for 5 over 4, you do 3 over 3.
Okay, good. So now, why did you pick those numbers?
Well, because the denominator would be 12 for both fractions.
Exactly. So what do we call that denominator? You're saying now the denominator would be 12 for both fractions, and you're so correct. What do we call that denominator? Its special name?
Greatest common factor.
Not greatest common factor, and it's not because the greatest thing they have in common, there is nothing. It goes on forever. 12, it could be 12 million. It could be 12 billion, 12 trillion. That's greater. That's bigger. So it's not the greatest common factor. And a factor is smaller. Factor of 4 is like 2. Like if I factored, where's this example? 4, it's really 2 times 2. That's factors of 4. If I factored 12, it's 2 times 2 times 3. Those are factors. And the greatest common factor between the top and the bottom, the greatest common factor of the two of them is 2 times 2 or 4. And that's why we're left with 1/3. But these are not greatest common factors. So the greatest common factor, GCF of num and den, numerator and denominator, is 4. So it's a small number. The GCF, or greatest common factor, of 4 and 12 is 4. But here, I started with 3 and 4. And 12 is the blank of 3 and 4. 12 is the blank of 3 and 4. Go ahead, Justin.
Is it the greatest common factor?
That's what Jabari just said, and I told him no, and we just had a whole chat about it. Look, greatest common factor. The greatest common factor of the numerator and denominator, here's 4 and 12, is 4. Okay, that was the example I gave you. The greatest common factor between 4 and 12 is 4. But now I'm asking you, 12, if we start with this problem, 12 is the blank of 3 and 4. And we said when the word greatest is actually a smaller number. It's like the opposite of what you would think. Like in foreign language class, we call that a false cognate. Okay? Like you might think the word nombre means number. Sounds like number to me. That's a false cognate. It means name. All right? It's a 3-letter expression. It's not GCF. Come on. Take a guess, even if you think it's wrong. Go ahead.
Greatest common denominator.
It's not the, guys, so if it's greatest, that goes up for infinity. Like 3 and 4, well, I could use 48. That's bigger. And they both can turn into 48. I could use 96. I could use 12 billion. So it's not the greatest. If it's not the greatest, what is it? Least. Ding, 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 ding. So it's the least, and it's still common. Least common what? Go ahead, just shout it out.
Multiple.
Sure, multiple or least common denominator. So guys, I need you to remember this moment right now because everyone mixes those up. Everybody, all the time. They see the word greatest and they're like, greatest means big. Like caveman, ooga, ooga. Me see great, me make big. Or me see big, me say great. But like, it's not. It's really totally the opposite. So here, the smallest, not the smallest, but a smaller number that is the biggest number that goes into both of them is the greatest common factor. You have a few factors, FF, okay? That is called assonance? No, alliteration. English class. Alliteration when words start with the same letter. So you have a few factors, but you have many multiples. That's my alliteration of the day. Okay, so these are least common denominators, all right, or the least common multiple. What multiples? You have many multiples. What are the multiples of 3? 3, 6, 9, 12, 15, 18, 21, ... What are the multiples? Multiples of 4? 4, 8, 12. Bing, bing, bing. First one they have in common. 16, 20, 24, ... Here, common factor is you make a factorization, right? And what do they have in common in the factors? So we're really going to practice those words. So now, starting from the top, here was the original problem. I asked you to add, and Paige was like, well, first thing we're going to do, I'm going to multiply this bad boy by 4 over 4. I'm going to multiply that bad boy by 3 over 3. We established that any number over itself is 1, and that is known as the multiplicative identity. And you sound so smart when you say that. Multiplicative. What a nice word. Sorry, I squeezing over here. Identity. That means you can multiply anything by it and it doesn't change its value. Kind of like the additive identity is a big fat 0. You could add 0 to anything, it doesn't change its value. Now what? Home stretch, guys. 8 over 12 plus 15 over 12. What's that equal? What does that equal? 8 over 12 plus 15 over 12. Help. What does it equal? Nobody knows. 8 over 12 plus 15 over 12. I know you know. Come on. Don't be a weenie and shout it out. If you're raising your hand, I can't see it because I have too many windows open. It's covering up the hand raise spot. No? Dylan, you don't want to tell me 8 over 12 plus 15 over 12? Or maybe Sol or Melvin? No one wants to tell me? Being bashful today? Thanks, Liana. What is it?
Is it 23 over 12?
You bet your butt. 23 over 12. And that's it. We are done-zaroonie. 23 over 12. Okay? Sometimes you could reduce or simplify even further, but that is that right there. So we had just a basic expression that we were able to simplify. That's sort of a little level 1 division happening. We have an addition simplify happening. Now, let's try something else. We got more time. Example 3. What if I asked you to simplify? Okay, don't panic. 2 plus 4 over 3 all over 5 over 6 minus 1. Oh my gosh, what the heck is happening? What is my teacher giving me? Why is she like this? Why does she have to be this way? What a big beefy problem, okay? 2 plus 4 over x all over 5 over 6 minus 1. Now, if this is scaring you, this is old stuff. We didn't even get to the algebra 2 stuff. There's no x here. We're going to be doing this with x's next, okay? X's are going to be thrown in the mix. So we need to know what to do with all of this stuff. So we want to simplify this. This is clearly not simple. This is not simple, and we need to make it simple. That's what simplify means. We're going to make it more simple. So what can I do to get started? Whenever you have something like this, just look at it one piece at a time, okay? No need to panic. No need to worry. We're going to look at one little piece at a time. So I want us to look at, say, I'm going to show you two methods for this. I'm going to show you the traditional method, and then I'm going to show you the Miss T method, where we're going to do it my way, which is way better, okay? And maybe that's a bias. It's my opinion, but you'll agree with me, I think. We'll see. Traditional method first, Miss T method second. Okay, here, traditional method. We might take the numerator and do exactly what Paige had us do in the last example. What is the 2 really over, invisible over here? The 2 is really over, A.
1.
Good, 1. So if I need a common denominator, least common denominator, what would the least common denominator be for the numerator? What's the smallest number that 1 and 3 could both grow into? If you count by 1s and count by 3s, what's the first number that they both overlap at? Count by 1s. 1, 2, 3, 4, 5, 6, ... Count by 3s. 3, 6, 9, 12, ... What's the smallest number they both can be if we count by them?
3.
Yeah. So 3 is the least common denominator. And what about on my denominator? What's the least common denominator down here? The 1 is really a 1 over 1. What number? If I count by 6, 6, 12, 18, 24, ... Count by 1s, count by 6. What's the first number they both hit? Multiples. That's how we get multiples. Multiple denominator. 6. Good. Yes. All right. So I'm going to take this over here. I'm going to multiply the numerator and denominator by 3. Not just one part of it, both parts, because we're multiplying by 1. Identity. Allowed to do that. And then the 1 over 1, I'm going to multiply on top and bottom by 6. Oops. Times. Then, next line. Going to the next step. 3 times 2 is 6 over 3, plus that 4 over 3 I'm not touching, over on bottom, 5 over 6 minus 6 over 6. Next step, combine like terms on top now that we have the common denom. What's 6 over 3 plus 4 over 3? And then what's 5 over 6 minus 6 over 6? 6 over 3 plus 4 over 3 is?
10 over 3.
Yes, thank you. Then 5 over 6 minus 6 over 6 is?
Negative 1 over 6.
Thank you, Dylan. Yeah, perfect. Next step. Now, I'm not using equal signs. I'm using arrows, and I'm doing this on purpose because I don't have an equal sign because it's an expression, and I don't want to get confused and think I'm solving an equation by sticking a bunch of equal signs all over, so I'm kind of drawing arrows, okay? Now, when you have a fraction divided by a fraction, you might have learned a 3-word phrase to help you remember what to do, because division is really the same as another operation. So we can turn this division problem, because who wants to divide that in their head? Not me. We could turn this division problem into what type of problem? What are the 3 words you might have learned a long time ago on how to deal with this? Does anybody remember? K word, C word, F word. Don't say a bad word.
Keep, change, flip.
You're the best. Thank you, Justin. Keep, change, flip. So some of you may have learned that. Keep, change, flip. I know I never really teach it that way, but since some of you know it that way. Keep means 10/3 we keep the same way. Change means you change this fraction bar, which means division. A fraction bar is division. So if you have a fraction and you're like trying to put in a calculator, the number of times a student's like, how do I make a fraction bar in a calculator? I'm like, it's the division button, guys. Okay? So instead of divide, we're going to change it. Change it to what? Multiply. Flip, we're going to flip the bottom. So I like to keep the negative on top for a case like this. So negative 6 over 1. Now, careful, but what can we do next? There's a cleaner way to do this, but what do we do in the next step? There's more than one right answer, what you could say right now. Give me something. Sean, Melvin, Asaya, Kennedy, Tahani, Hashara. Who else is here? Ariel. What else? What else? Go ahead, Adriana. What do I do in the next step?
Cross multiply.
Okay, everyone loves that phrase, cross multiply. The issue with that is, I'm going to show you what cross multiply is. That's why I try not to use that phrase myself, because I feel like it creates a bad environment. If you had like x plus 4 over 3 equals 5 over 6x. If you have that equal sign in the middle, then what you might do in the next step, people would say you cross multiply. Cross multiply. But I hate that, because a cross, like even in like religious symbols, right? A cross might look like more like this, right? A vertical and a horizontal line. So you might think like a cross or up and down or something like that, but it's more like a diagonal process that we do over here, right? So you would do 3 times 5 on one side, you get 15. The equal sign stays, and then you would do that. 6x times x, you would get 6x squared, and then you would get plus 6x times 4, 24x, all right? But that's cross multiply. I like to say, whenever I see a problem like this, you're going to say to yourself, what is this symbol called? What's this symbol I'm tracing over called? What is this? This is a...
Equal sign?
No, it's a caterpillar. And what's the caterpillar's goal in life, Jabari?
Turn into a butterfly?
Yes, beautiful. Help it reach its goal. So when it turns into the butterfly, the caterpillar is still in the middle. So you don't lose that equal sign, okay? The caterpillar is still in the middle. So when you said cross multiply, we associate that with this diagonal thing. But this, maybe you might think across. You multiply across. So side to side, all right? However, we always want to think smarter, not harder. So how could we think smarter? Okay, here's a better way. Anytime anything's connected with multiplication and division only, that's the glue, the Velcro holding this together, you can reduce anything from the top to anything on bottom, with anything on bottom. So do we have numbers in our numerator that would reduce with numbers in our denominator? And really that 1 doesn't even need to be there. Can I reduce anything from the top with anything on the bottom? What can I reduce?
3 and 6?
Yeah, 3 can reduce with the 6. So 3 really becomes a 1, which I don't need to write. And 6 becomes what?
-2.
2, good, or
-2.
-2, exactly. So then we multiply. So the numbers are smaller. 10 times -2, -20. And then that's 1 and 1, it's over 1. So done. That whole gross ugly thing equaled -20. So that's the more traditional way to do this. And guess what? I hate that way. So I'm going to bang out the Miss Thomas method right now. So back to this. So the directions will be simplify. This is going to be very quick, and it's going to take a little practice. And then I'm going to give you the homework at the end of this video, and you're going to do that on your own and submit that. But we're going to simplify 2 plus 4 over 3 all over 5 over 6 minus 1. Now, what we do for the Miss T method is we're going to look at all of our denominators. 1, 1, 3, and 6. And we're going to say to ourselves, overall for the whole problem, what is the least common multiple or least common denominator? If I count by 1s, count by 3s, and count by 6s, what number is going to be on all those lists? Help me out, quick. What number will be on all 3 lists, counting by 1s, counting by 3, and counting by 6?
3. Wait, no.
6.
6, yeah,
My bad.
6. So what you do is you take that least common denominator or least common multiple, same idea, which is going to be 6. And we're going to multiply the whole top, big parenthesis, by 6. And we're going to multiply the whole bottom by 6. So it kind of makes it look like when you put those big parentheses, like a hamburger. So here's your bun on top, big parenthesis. Here's your bun on the bottom, big parenthesis. And then there's your burger in the middle. Very flat burger, but there it is. Now, think smarter, not harder. We always try to reduce. Make your numbers smaller before they're bigger. We're going to wrap this up, okay? Almost done. 30 seconds. Question, Liana?
No, I accidentally unmuted.
Okay. So we're going to distribute that 6. 6 times 2 over 1. Try to reduce first, but that's just the 1 on bottom. 6 and 1, who cares? So we'll get then 2 times 6, and I get what for the next step? Well, 6 times 2 over 1 is 12. Okay, great. Plus, now here, 6 times 4 over 3. Think smarter, not harder. Reduce. 6 and 3 reduce and give me 2. 2 times 4 gives me what? 2 times 4, that's 2. Times 4 is?
8.
Bam. Fraction bar. Do the same on bottom. 6 times 5 over 6. Don't tell me 30 over 6. Don't be a weenie. Reduce it first. Think smarter, not harder. 6 and 6 reduce to 1. Adios. 6 and 6 reduce. It's totally gone. And we're left with just 1 times 5, which is what?
5.
5, exactly. Minus sign, all right. 6 and 1, try to reduce. It's still 6. Times 1 is 6. Look at how cute that is. Isn't that so much cuter than that mess we just made using a very traditional approach on the left? Like, ew, ew, gross. So keep going. 12 plus 8, what do we got? Not all at once. I might fall out of my chair.
20.
Thank you. And then 5 minus 6?
1.
1, but what kind of 1? 5 minus 6 is?
-1.
Thank you. -1. -1. Good. And final answer. There you go. It's just -20. You don't need, there you go. You don't need to 1 on bottom, and we try to move our negatives to the numerator whenever possible. How much better? Come on, guys. That was so beautiful. Now, that was the Miss Thomas method, okay? The Miss T method. Question page before I write down the homework for everybody.
I think there was a section with the X's. I didn't get to copy that down. Like you were working with X's.
I don't know. I don't think so. No, I didn't do anything with X's yet. I was talking about it. I said, like, we're going to eventually have X's, but we don't have it yet.
Oh, okay.
Okay? No worries yet. Maybe it's something in the earlier. Oh, you maybe were thinking of this guy because we were just talking about what cross multiply is. That's what cross multiply is. I'm writing down the examples I want you to try on your own. On your own. You're going to have 3 examples, and they're going to model this. And this video of our class on your model, because I said the word model. This video will help you if you needed to compare what you have to do on your own with something we just did, so you could model it after that, okay? So we're going to simplify 3 different things. So number 1, I'm writing it on the side over here, but that's number 1. Number 2, I'm writing over here. Number 2 I wrote down. Sorry, it's taking me a minute in case you had to copy that. And then here's this again if you need to look at this, okay? So traditional method and Miss Thomas method. And we're going to do one more. And this will be just a little bit of a change up over here. Okay, here are the examples that I want you to do on your own. So the directions for all of them is going to be simplify. That's what we're working with right now. Roman numeral 1 of the 2 Roman numerals I wrote down. We're going to simplify these examples. Number 1, -3 over 7 plus 4 over 5 minus -7 over 10. If you just punch it in a calculator and write down an answer or show like half a step because you're using a calculator, you don't get the credit for it, ladies and gentlemen. So please make sure, and also please write that you were present today in the chat right now so that I don't mess that up when I do attendance later. Okay. And here we go. Now, if you need any help doing this, you can come to office hour and I will happily help you. You know that. These are very similar. I just threw in an X, a little sneaky, but it's the same concept. I threw in an X a little bit on top and bottom. You're going to treat it the exact same way though. Nothing changes. Your answer will just look a little bit different. And that's it, I guess. So some of you have an email from me. Check Classroom, check your email, and you have an appointment with me at 10:15. This is your assignment to work on. If you think you can do it and you plan on doing your homework, or if you're watching this video because you're doing your homework and you're using the video for help, put thumbs up. And if you are confused and that's why you're watching it, you could put a thumbs down. I don't care. I don't know who does it. It's anonymous. If you are watching the video, if you scroll around and watch at different parts, if you could put timestamp comments, that'd be great, because then we could timestamp, like example 2 is at this time, example 3 is at this time, traditional at this time, the Miss T method at this time. This way you guys could find those times. You write the time out and find those times and it'll jump you right to there. Okay, so that is the end of this recording. And I think Manuel, you have a question, right?